Okay, the unit circle, what all of trigonometry is based on. We are going to look specifically at 30, 60, 90s and 45, 45, 90s. Okay, so if we have, I'm going to draw a probably not very good triangle. You may or may not have derived the 45, 45s and the 30, 60s last year. I don't know. Don't forget your degree symbols. From geometry, we know that the side opposite the 30 degrees is x. The side opposite the 60 degrees is x root 3. And the hypotenuse is 2x. That is the relationship in a 30, 60, 90. In a 45, 45, 90, opposite the 45 is x, x, and then the hypotenuse is x root 2. Okay, if I tell you that the hypotenuse is 1, so I'm going to tell you that the hypotenuse is 1, and I'm going to do that for both triangles. You can solve for x. So if the hypotenuse is 1, that means that 2x equals 1 in the 30, 60. Therefore, x is 1/2. So given a hypotenuse of 1, opposite the 30 becomes 1/2. And opposite the 60 becomes root 3 over 2. 1/2 root 3, same thing as root 3 over 2. Again, this only works if the hypotenuse is 1. In a 45, 45, 90, if I give you the hypotenuse is 1, you can solve for x. It means x root 2 is 1. Divide both sides by root 2. Which of course is not allowed. Rationalize and you get root 2 over 2. So in a 45, 45, 90, if the hypotenuse is 1, then each side is going to be root 2 over 2. We just solved. Okay, why does this matter? Well, in the unit circle, the radius is going to be 1. So I'm going to pause and draw a nice circle. Voila! Here is my circle. All right, and what I'm going to do is I'm going to impress this circle on a coordinate plane. Draw in an XY axis. This is my unit circle, huh? What's a unit circle? A unit circle has a radius of 1. By definition, the radius is 1. So I'm going to draw in some radius. How about here? From center of the circle to the edge of the circle, that's a radius, and I'm telling you that it's 1. Okay. Well, the whole reason I did this thing up here with the 30, 60, 90s and the 45, 45, 90s is I'm going to take these triangles and I'm going to impose them inside the circle. So I'm going to start with the 45, 45, 90. I did not measure with a protractor, nor am I going to measure with a protractor. You don't need to either. I have some triangle and it's not exactly 45 degrees, but I'm just going to tell you that it is. If you wanted to, obviously you could use a protractor, not necessary. Okay, notice that the radius of this circle is the same as the hypotenuse of the triangle. The radius of the circle is the same as the hypotenuse of the triangle, and the radius is 1. So because the radius is 1, and I already figured out that's the same as the hypotenuse of my triangle, well, 45, 45, I said that the hypotenuse was 1. I already know the lengths of the two sides. So the lengths of the two sides are going to be root 2 over 2, root 2 over 2. Based on the relationship of x root 2, I told you the hypotenuse was 1. We solved for x, root 2 over 2, root 2 over 2. I just imposed that onto my triangle. Okay, that means that the coordinates of the point right here on the circle, x, root 2 over 2, so x, right, left, yeah, the horizontal axis, root 2 over 2. Vertical, that's y. The coordinates are root 2 over 2, comma, oops, that's not very good. Root 2 over 2. Let me get some white out. Let me fix that. You get the ordered pair, root 2 over 2, root 2 over 2. Okay. Now, I could do the same exact thing for a 30-60, and I'm going to demonstrate that in quadrant 2. So I have some angle, and I'm not going to draw it exactly. It's a radius. The radius is 1. But if I impose a triangle into the circle, I have created a right triangle. And again, I didn't measure, but I'm just going to say that this is 30 degrees. Okay, so now I have a 30, 60, 90. The hypotenuse is 1. That's what I just did up here. And so we said, okay, if the hypotenuse is 1, then x is a half. Hypotenuse is 1, x was a half. So opposite the 30 degrees, this is the key point right here. Opposite the 30 degrees is 1/2. So opposite my 30 degrees is going to be 1/2. Adjacent to the 30 degrees, adjacent to the 30 degrees is root 3 over 2. Notice that the adjacent to 30 is the same as the opposite of 60. The adjacent to 30, root 3 over 2, is the same as the opposite of 60, root 3 over 2. That's going to be here. This, of course, has to be 60 degrees. The adjacent to 30, root 3 over 2, which is the same as the opposite of 60. Now, I'm in quadrant 2. I'm in quadrant 2, so it must be negative. So if I want to figure out the coordinates of this point right here, the coordinate is x comma y. So in this particular case, it is negative root 3 over 2, 1/2. That says negative root 3 over 2. I fixed it, negative root 3 over 2. Okay. Let's talk about SOHCAHTOA. Let's talk about SOHCAHTOA. So you learn SOHCAHTOA whenever it is, and you have the sine of some angle, and we're going to use theta now. We're always going to use theta, no more x and y. Try a better color. It's not much better. The sine is the opposite over the hypotenuse. And the cosine is the adjacent over the hypotenuse. And the tangent, do not say tan. Tan is a color. Tan is something that happens to your skin when you lay out by the pool for too long. Tangent is a mathematical operation. I lost my train of thought. Opposite over adjacent. Okay. You should never have to draw triangles anymore. And here's why. I'm going to draw a triangle to show you why you don't need it anymore. Let's talk about the 45, 45 since I have it right here. So opposite the 45 degrees is root 2 over 2. Adjacent is root 2 over 2. The adjacent side is also known as x. The opposite side is also known as y. So let me put that all together in a new picture without the circle. In the unit circle, the radius is always 1. There's never an exception. Radius is always 1. Okay, so based on the fact that the hypotenuse slash radius is 1, opposite the 45 degrees is root 2 over 2, and because it's an isosceles right triangle, the adjacent is also root 2 over 2. So all I did was, to start with, I did the geometry and figured out the root 2 over 2 part. Then I took this triangle and I kind of turned it sideways and I put it in the circle. And then we just, okay, mapped it out. And that was the ordered pair root 2 over 2 comma root 2 over 2. Now I'm taking it out of the circle. All right, if I ask you to find the sine of 45 degrees. Okay, the sine of 45 degrees is the opposite, which is root 2 over 2, over the hypotenuse, which is 1. So isn't that just root 2 over 2? Same thing would be true for the cosine. Same thing would be true for the cosine. I'm not going to write it down. Let's do tangent. Okay, the tangent is opposite over adjacent. You learned that in geometry or whatever it was that you learned it. In the 45-degree triangle, opposite is root 2 over 2 over adjacent, which is root 2 over 2, which is 1. When Ms. Babiak, you said I wasn't going to have to draw the triangle anymore. And you're not. Any triangle in the unit circle. This is what happens when I don't draw it. When I don't trace a circle. You have some angle theta. And the hypotenuse is 1. All the angles have all the triangles have a hypotenuse of 1. All of them do. The radius is 1. The radius is the same as the hypotenuse. You need to make sure you have a strong grasp of that concept. Radius of the circle is the same as the hypotenuse of the triangle, which is always 1 by definition of the unit circle. So if I ask you to find the sine of some angle theta, that's going to be opposite over hypotenuse. But isn't the hypotenuse 1? So isn't the sine of theta just equal to the opposite side? Sine, opposite over hypotenuse. Hypotenuse is 1. Opposite over 1 is just the opposite. But isn't the length from the center going to the horizontal distance, isn't that x? And isn't the distance from the x-axis up, isn't this vertical distance y? So isn't the opposite side the same as y? Cosine. Cosine is adjacent over hypotenuse. The hypotenuse is 1, so isn't the cosine the same as the adjacent side? And isn't the adjacent side the same as x? In the unit circle, The x coordinate is the cosine, the y coordinate is the sine. The ordered pair of on the unit circle, x is cosine, y is sine. So you don't have to draw triangles anymore if you know the ordered pair. And I'll do a couple examples. Tangent. Okay, the tangent. Tangent is opposite over adjacent from your SOHCAHTOA days. Didn't we just figure out, though, that the opposite is the same as y? And didn't we figure out that the adjacent is the same as x? So tangent is y over x, which is also sine over cosine. So let's look at different angle, and let's find the value of the functions. So let's look at, how about, it's 135, let's do 225. Theta is 225 degrees, and I want you to find the value of all 6 functions. Whoa, 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 whoa. 6 functions? We only talked about 3, sine, cosine, and tangent. I think you may have heard of these, but if not, we will review it. The reciprocal of the sine is the cosecant. The reciprocal of the sine is called the cosecant. The reciprocal of the secant is the reciprocal of cosine is the secant. The reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. These are the reciprocal functions. So if cosecant is the reciprocal of sine, cosecant is also known as 1 over y. Secant is 1 over the cosine, so that is 1 over x. And the reciprocal of tangent is x over y, sine over cos, or cosine over sine. Let's figure out, where is 225 degrees? Where is 225 degrees? Okay. So I know I told you that you weren't going to have to draw any more triangles, but until you get good at it, you're still going to need to draw a triangle. So first, let's figure out where 225 is. So 225 is in quadrant 3. Until you get good at it, you're going to want to draw your triangle. Some of you may have memorized the unit circle last year. Not sure if you did. I personally do not recommend it. I think it's too much to keep straight in your head. What you really need to know is your 45-45 and your 30-60. So if this is 180 degrees, the x-axis represents 180 degrees. I have gone 45 degrees past 180. So 45 degrees is known as the reference angle. Your triangle, if you choose to draw one, is always from the x-axis. So I just drew from my terminal side to the x-axis. Okay, So I'm going to go back. Opposite the 45s are root 2 over 2. Opposite the 45s are root 2 over 2. So when I draw this triangle in the third quadrant, it's going to be root 2 over 2, sort of. Opposite side, root 2 over 2. The adjacent side, root 2 over 2, not really. What am I forgetting? Negatives, because I'm in quadrant 3. I'm in quadrant 3, so it's negative root 2 over 2, negative root 2 over 2. Okay, so on the unit circle, this point right here is negative root 2 over 2, negative root 2 over 2. And now you can answer all the questions. Now you can find sine, cosine, tangent, cosecant, secant, cotangent. So cosine is, where am I at? Cosine is x. The x coordinate is negative root 2 over 2, and so is the sine. So the sine of 225 is negative root 2 over 2. So is the cosine. The tangent, y over x, sine over cosine, 1. The cosecant is the reciprocal of the sine, and the reciprocal of the sine is going to be negative root 2. If you take the reciprocal, then rationalize, I couldn't think of the word. The secant of 225 is also going to be negative root 2. And the cotangent of 225 is going to be 1. Okay. What happens if you're asked to find like sine, cosine, tangent, cosecant, etc., of an angle that doesn't have a triangle? What does that look like? So what happens, you have something like 90 degrees, pi over 2, 180 degrees, pi, 270, 3 pi over 2, and any multiple thereof. All right. I'm going to draw I wish I could draw better. Oh my gosh. Okay. So pi over 2, 90 degrees, pi, 3 pi over 2, and then 2 pi. And you go around and around and around and around. The radius of the unit circle is 1. The radius of the unit circle is 1. So this point right here is 1, 0. This point at the top here is 0, 1. Pi is negative 1, 0. And 3 pi over 2 is 0, negative 1. This is where knowing that the ordered pair is cosine, sine, there is no triangle to be drawn. This is where knowing that tangent is y over x or sine over cosine is the only way you're going to be able to figure it out. So if I ask you, if I tell you that theta is, how about 7 pi over 2? Theta is 7 pi over 2. Okay, well, where's 7 pi over 2? I believe 7 pi over 2 is at the same place as 3 pi over 2. If you were to go around, and you would go around and around and around, you would end up at 3 pi over 2. Rather than continuing to write 7 pi over 2, I'm just going to say theta is 7 pi over 2. So therefore, I can just do sine theta if I'm using theta 7 pi over 2. So the sine of 7 pi over 2, 7 pi over 2 is right here. The sine is y, get -1. The cosine is x, that's 0. Tangent. Tangent, sine over cosine, that's going to be -1 over 0, undefined. It is not no solution. It is not 0 with a line through it. Cosecant, reciprocal of the sine, -1. Secant, reciprocal of the cosine, undefined. If you want to abbreviate, it's fine. But it is not 0 with a line through it. You will not get credit for that. You will lose points if you write that. It's not true. And it's not no solution. We're not solving, we're simplifying. We're evaluating is essentially what we're doing. And the cotangent would be 0. The cotangent is cosine over sine. Cosine is 0 over -1. That's allowed. So putting it all together, in the unit circle, the ordered pair represents cosine comma sine. Tangent is sine over cosine. Cosecant, 1 over sine. Secant, 1 over cosine. And cotangent, 1 over tangent, which is also cosine over sine. Okay. This, I would say, is the most critical. But before even that, you must understand the relationships in the 30, 60, 90, 45, 45, 90. Opposite the 30 is 1/2. Adjacent is √3 over 2. If you want, I usually don't draw the 60, but I think some of you may want to see it. And then 60. Opposite is √3 over 2. Adjacent is 1/2. They're switched. So notice sine is opposite. That's 1/2. For 60, sine is √3 over 2. And then so the sine of 30 is the cosine of 60. The sine of 30 is the cosine of 60. Then we have 45s, which is √2 over 2, √2 over 2. And then 2 more things that I would just make sure I understood. And that is I would know my ordered pairs, that this is 1, 0, 0, 1, -1, 0, 0, -1. I get this question more than any other question. How am I supposed to find the tangent of 360 degrees if there's no opposite, etc.? It's because you know that the ordered pair is cosine sine. So if the angle is on the axis, you can still evaluate it. And then the last thing, and when I do problems, I'll probably do this quite a bit. I don't like to always draw the triangle. I don't need to because I've been doing it forever, but in the first quadrant, positive, positive. X is positive, Y is positive. In the second quadrant, X is negative, Y is positive. In the third quadrant, you have negative, negative. And in the fourth quadrant, you have positive, negative. So if you know your first quadrant, then all you need to do is make adjustments for the positives and negatives depending on the other quadrants it's in. If you know your first quadrant, you know all your quadrants. So I'm opposed to memorizing the unit circle. If you've got it down pat, fine. But this right here is the key to your entire trig life, right here. Obviously there'll be more, but that's it.